Hello everyone. Today we'll be discussing this research paper, study on implementation method of agent-based advanced RAG using graph. Okay, there's three key terms: agent-based, advanced RAG, using graph. Okay, we will discuss it in detail. We won't go into detail. We will do a very quick overview, we can say. Since we already know the RAG part, we'll just try to go for the advanced RAG. Okay, we know what is RAG, retrieval augmented generation. We do the retrieval part from the document and then the generation, and there is a image here showing this part. We have the PDF with the extraction, the splitting, we get the chunks, then there is embeddings, we got a vector store. Okay, and then there is LLM calls, we extract the relevant chunks and do the generation part. Okay, so simply it was saying that how this is the basic RAG process. So if you want to improve it, there are various methods. The suggesting is that we can divide a retrieval process in three stages: pre-retrieval, retrieval, and post-retrieval, and then we can go on improving each part. Okay, and there is a very important table here said the method to enhance the GAN performance. Okay, so these are, you can say, important, or you can use, we can use it in real projects. First is cleaning your data. Second is exploring different index type. Okay, so we written that while embedding based similarity search methods generally perform well, they are not always the best solution. For example, in e-commerce, we search best laptop under 3,000 rupees, or laptop with 6 GB RAM, 8 GB RAM, these specific terms. So we can use key based search method during that time. So we can explore different type of indexes. Experiment with chunking approach. Okay, we can vary the chunking size, overlap size. So this may change our RAG system, like performance. Play around with our base prompt. Definitely, here is suggesting that use the answer you generated from the RAG. Use the retrieval passes only for generating the answer. Don't hallucinate or don't use your patent knowledge. So please answer questions based on the given context information, not on patent knowledge. Okay, and try the metadata filtering. Okay, so along with the data we retrieve, we also include metadata like topic, page number, or chapter name. So these things can be used. Use query routing. So this part was interesting. Having multiple indices is beneficial. Like when a query is asked, you can decide, okay, I can use similarity search now, I can use k-based search now. So like we can use multiple indices and decide like which one will be better for this case. Looking into re-ranking. Okay, after retrieval is done, we can re-rank the extracted passes on basis of relevance or other factors. Okay, consider query transformation. This part is also good. Like when we ask question, we only we can do like we can change the query, like make it a make it look like a better prompt. Make it like a better prompt for our algorithms. This is fine tuning. Okay, and there is then research on the advanced GAN types. Okay, we already know several self-RAG, RAG plus reflection part. In the paper we read on self-RAG, we use reflection tokens. Remember whether to retrieve or not, is relevance or not, is support or not, like these things, is useful or not. And there is other corrective RAG. It also feels a bit similar. This approach employs a corrective agent to rectify errors. Okay, there is also agent to improve, like to find errors. There is self-RAG, we know. Corrective agent is a bit similar. We have an agent there to rectify the errors and generate responses. Great. And there is adaptive RAG, which in basically there is like a method which we have to choose. It includes both self-RAG and corrective RAG, but we have to decide when we will opt self and we will go for corrective return. Okay, like there will be a setting. So for this cases we will go for self-RAG, for this cases we will go for corrective RAG. Okay, let's do a bit quicker. Okay, so how this is the advanced RAG flow. Okay, we just try to walk through it. We ask a question, we already have retrieved of VectorDB. This is document. Okay, document is retrieved. We'll decide it is relevant or not. If yes, then do the generation part, like answer the question. If no, then rewrite the query, do the web search, then generate. Are you getting my part? Like we know the basic about what is our basic workflow. There is a vector DB. There is also document. From that we will extract the relevant documents, or like the question asked, document related to that. And if the document is found relevant, then do the generation. If the document extracted is not relevant, then don't do the generation and do the other. This is other path. And what is the other path? We rewrite the query, we do the web search, and then do the generation. And for doing the web search, we need tools. So here we use Tableau tool, and this is the there comes the use of agents. Like without agents, we can't do this. Agents use tools to form actions and say that in that way. Okay. Well, this is the table part. We use Py PDF loader to load the document. And they also was splitting. There are two types: character text splitter and recursive character text splitter. So recursive one was better. Actually, for splitting, it uses a list of characters. Okay, we can check it. We can go in detail later. Okay, so this was basically the main graph. The graph, you can see there are nodes, there are edges. I use langgraph to implement this. We are using langgraph.graph here. Okay, so this gives a very good overview of the entire project or paper. So there is a start. We then retrieve the passes, and when they decide, there's a great document. Think of it like a function or something, where you decide if the retrieved passes is relevant or not. Okay, if it is relevant, then directly go to generate answer, like generate a response using LLM. If it is not relevant, okay, then rewrite the query. Okay, let me show you. There's rewrite the query. Okay, they will define. They've already defined. Okay, this is, see this, rewrite the query, rewrite prompt, act as an action writer and perform the following task. Convert the following input question into better version optimized for web. When rewriting, look at the input question and infer it underlying semantic intent. Okay, so understand the intent and rewrite it. And after rewriting, do the web search using Tableau API. Here written web search button. This using Tableau search result. We're retrieving two passages, advanced max tokens, great. And if we found the web search, we generate the answer. And if we find that even using web search we didn't get any like useful passes or not, then we like go in the loop till we get a suitable answer. Okay, we can keep like a number, go for 5 times, 6 times. We can keep like how many times the max we can go for the loop, then go for the final generation. So this is basically the basic overview of the paper. Okay, there's much more. You can just go through the paper. This was the very basic part. So there was a limitations. It was saying this work was basically a mode or domain specific. The LangGraph based system is optimized for specific domains, which may result in performance degradation when applied to other fields. Okay, so this part is important. And also it is saying that other than advancing, like focusing on improving the React technology, we can also focus on like improving how the information is retrieved and how accurate and reliable answer is generated. This is just saying that the other part to advancement to improve our overall system. Great, are there many more things. You just try to go over the paper. Since I already read like React and Drag and Self-Drag, so things are a bit easy on the easier side. Okay, there's also a recent paper of July 24. Okay, then great. Bye bye till then. Fix full screen.